Good afternoon, everyone. Today we are going to discuss about the topic from engineering physics, which is moment of inertia of oxygen and hydrochloric acid molecule. How difficult is to rotate a particular object? The answer depends on the shape of the object and where the object's mass is concentrated. So, for example, the moment of inertia is fairly slight in a wheel with an axis in the middle. All the mass is evenly distributed around the pivot point, so a small amount of torque on the wheel in the right direction will get it to change its velocity. However, it's much harder and the measured amount of inertia would be greater if you try to flip the same wheel against its axis or rotate a telephone pole. Moment of inertia. The moment of inertia of a molecule may be defined as the product of mass of each atom and the square of the distance from the rotational axis through the center of the mass of the molecule. The moment of inertia of an object is a calculated measure for a rigid body that is undergoing rotational motion around a fixed axis. That is to say, it measures how difficult it would be to change an object's current rotational speed. That measurement is calculated based upon the distribution of mass within the object and the position of the axis, meaning the same object can have very different moment of inertia values depending upon the location and the orientation of the axis of the rotation. The SI unit of moment of inertia is 1 kg per meter squared. In equations, it is usually represented by the variable I or IP. Calculating moment of inertia. Measuring the distance r from any particle in the object to the axis of the symmetry. Square the distance. Multiply that square times distance, the mass of this particle. Repeat for every object particle and add all those values up. Now moving on to the moment of inertia of HCl molecule. Let's assume the mass of the hydrogen be m and mass of the chlorine be 35.5 meter according to the picture. And given that separation between two atoms is 1.27 into 10 raised to minus 10 meter, and let the center of the mass for molecule be x angstrom distance from the chlorine atom, then the distance for one-dimensional center of mass Cm is calculated by using the same formula Cm equal to m1x1 plus m2x2 whole divided by m1 plus m2. Substituting the values which was taken before into the whole equation gives us the angstrom as minus 0.037 into 10 raised to minus 10 meter. Here we have the negative sign, but negative sign just indicate the Cm lies left to the chlorine as assumed according to the figure, and it lies at a distance of 0.037 into 10 raised to minus 10 meter. Now let's move on to the moment of inertia of O2, oxygen molecule. Given mass of each oxygen atom as 2.67 into 10 raised to minus 26 kg per meter, and distance of each oxygen atom from the axis of rotation as 0.6 into 10 raised to 10 raised to minus 10 meter, which is as therefore moment of inertia is equal to I equal to mr square plus mr square equal to 2mr square L. Substituting all those equations in the formula, we get 1.922 into 10 raised to minus 46 kg per meter square. Concluding, now we get moment of inertia is just a calculation of the required force to rotate an object. The value can be manipulated to either increase or decrease the inertia. In sports such as ice skating, diving and gymnastic, athletes are constantly changing their body configuration by increasing the radius from the axis of rotation. The moment of inertia increases, thus slowing down the speed of the rotation. Alternatively, if an athlete wants to increase the speed of the rotation, they must decrease the radius by bringing the segments of the body closer to the axis of rotation, thus decreasing the radius and moment of inertia. Thank you for your time and have a great day.